welcome. Today we're going to have a nice conversation with Zongheng, creator of the SkyPilot. Can you tell me a little bit about what is the SkyPilot?
Yeah, so SkyPilot is an open source platform for bringing all your AI compute into one place. It is actually an open source project we started back in UC Berkeley, and we were looking at the GPU shortage problem, right? And our lab actually had the fortune to receive a lot of cloud credits from different clouds.
Right.
And the funny thing is we saw all the researchers only use AWS because they didn't want to learn how to use other clouds. And we were telling ourselves, we are wasting money, right? Like this, all these GPU credits, can we have a simple way to access all of the GPU compute, right? And so that's how the project got started. A lot of companies picked it up, and then it grew from there. From my perspective, if you look at the most important software infrastructure companies in the last 15 years, right, most of them are open source, right? Or they started with open source. If you think about companies like Databricks, Confluent, HashiCorp, Redis, MongoDB, right, or Temporal, many of them, they started with open source. They are still very open source focused, and many of them became AI unicorns, right? Temporal is a great example. They started with durable execution workflows, but now they become the backbone of AI agents, right? And so I think the reason people prefer open source in the industry is if you are really talking about critical software, infrastructure level, right? People want to be able to trust it, right? They want to be able to see it. They want to be able to adapt it, right? If they need to. And so open source really goes a long way to help with that trust, right? Compared to some black box SaaS for application level thing, maybe you don't need that, right? But if you're talking about software infrastructure, critical for your AI journey, critical for your AI models, I believe people will buy open source.
Okay. At the beginning, I guess it was you and a couple of friends who decided, but now you have a big community. Is it quite active community?
Yeah. No, we have around 240 contributors today. Wow. They actually came from all sorts of cloud providers, including Nebius, right? We actually work with Nebius team very closely about, improving Nebius integrations and so on. The entire Nebius stack, such as managed Nebius Kubernetes, managed VMs, Operator, they're all supporting SkyPilot. So thanks to our partnership. We also have contributors from users of all these clouds, right? Maybe you're using Nebius, maybe you're using some other clouds. And we typically welcome contributions from all these people because they can catch a lot of deployment scenarios, right? As a core development group, we may not be able to catch every single edge case, right? Yeah. But if people use SkyPilot in production, they can see all sorts of scenarios. They can improve it, they can make contributions to it, so that's really helpful.
Nice. Thank you for a great overview of the history of the SkyPilot, how it was born. But what's the biggest problem in infrastructure today, from your point of view?
I think it's got to be capacity, right? Everybody is talking about capacity. There's not enough capacity. GPU clouds like Nebius, you want to buy more. So I think capacity remains a huge problem. However, I also think once you get some capacity, right, as an AI company, you get some capacity, getting the ROI from the initial capacity is also a non-trivial problem, right? You have some GPUs, you want your research team to run as efficiently as possible. You want frontier lab level capabilities and convenience, right? So I think people kind of underestimate both the capacity problem and then also getting ROI from the capacity.
So you said that you want to create something that allows to use multi-cloud without actually learning of them.
Yeah.
That sounds like you created several abstractions of the AI clouds, of the clouds in general, correct? Is there something still missing in terms of abstraction?
That's a really great question, Alex. I don't know if this is an abstraction problem, but a very big debate right now in the industry is Slurm versus Kubernetes, as you very well know, right? It's a hot topic. It's like the holy war. It's like Vim versus Emacs, but for AI infra. Slurm is really good for AI researchers. It's very easy to get started, right? But Slurm can have some shortcomings in terms of infra capabilities, right? This means not easy support for auto scaling, right? If you want to scale beyond a fixed set of resources. This also means it's not as dynamic. If you want to do something like RL, right? RL nowadays is very dynamic. Some stuff is running on CPUs, some stuff is running on GPUs, different kinds of GPUs. How do you talk to each other on Slurm? So I think, Slurm is not perfect. Kubernetes is similar story, right? Like it's really good for infra people, for infra teams. But it's designed for web serving, right? For microservices. Like, I think the problem we see right now is a lot of AI teams try to retrofit some abstractions on either of these platforms, right? They may take Slurm, they may take Kubernetes, whatever, and they trying to build some in-house solutions on top to make them easier to use, right? So I think that is a big problem, and that is a repeated kind of effort, right? We believe there should be a one-stop platform, turnkey solution to bridge the gap between AI research and AI infrastructure.
You were talking about the Slurm Kubernetes.
Yeah.
But have you abstracted them as well?
I think what we are doing is we are taking a new approach, right? We are not saying everything can be abstracted. We are not saying complexity doesn't exist. What we do is an unopinionated approach where you bring your platform of choice, right? You may be a company that prefers Slurm. That's okay. You bring into SkyPilot. You may be a company that prefers Kubernetes. That is okay. You bring into SkyPilot. What we do is we take your platforms, right? It can be multiple clusters, multiple clouds, and we offer values on top. For example, we offer AI-friendly abstractions on top, regardless of whether you use Slurm or Kubernetes or virtual machines. The second thing we offer is, of course, multi-cloud, multi-cluster support, right? Because when you're on, let's say, Nebius, managed Kubernetes, this year you may only have one cluster. 6 months later, you are scaling your AI team like crazy, right? You may want to add a second cluster and so on. Then suddenly it becomes a multi-cluster problem, right? So SkyPilot provides both the multi-cluster support and also the abstractions for AI teams.
Okay, interesting. And at the very beginning, when we're talking about the history, you said that one of the key problems was the multi-cloud.
Yeah.
Does people really use multi-cloud, or are they only talking about it?
It's very surprising to me as well. I think it's more real than we thought. Let me break it down into two parts, right? One, do companies use multi-cloud to do AI, right? About companies. The second is, for a particular type of AI workload, do they use multi-cloud? I think for the companies, it's very, very real. Like everyone we work with, from 10-person new lab, right, to 5,000 people enterprises. If you want to do anything with high-end GPUs, such as B200, H200, you just cannot get them from one place, right? You have to call your provider, say, hey, are you sold out? Are you sold out, right? Are you sold out 6 months in advance? You will be lucky to get some GPUs today, and typically what we see people do is they try to get as much as they can, right? Projecting maybe 1 year out, 2 years out, and you have to get them anywhere you can. So that's about companies. I think it's very, very real. Now about workloads, I think it depends on the type of workloads. If you're talking about large-scale pre-training, at least quite a few frontier labs I know, they're doing this, right? They're splitting one pre-training run across multiple clusters and clouds. It's very hard to do.
Yeah.
You have to handle networking, you have to handle gradient aggregation and all sort of things, right? But they have no choice, right? They have to train a huge model. They have to use as much compute they can. Right?
Okay.
So I think across the entire AI lifecycle, we see a lot of multi-cloud.
But what about the data?
People in the industry is trying to address this problem using economic incentives, right? Hey, if you put data in this object storage, when you move them out, right? When you read from that data set from different places, you can actually use it for free, right? And so I think that removes a lot of economic problems. In terms of latency and how long does it take to move my data, I think it certainly depends on your data set, right? If you're talking about 100 petabyte, if your training runs need to read 100 petabyte of data, that's tough, right?
Yeah.
Rather have it in one place. But most Gen AI applications we see, they are like maybe 10 terabyte, 30 terabyte or something like that. It's actually quite easy to move data. And people may prefer moving the data or replicating the data, rather than having my entire research team waiting idle, right, sitting idle on one place, waiting for the GPU availability to come back.
Okay. I think it's really interesting how many different layers you are changing with the SkyPilot.
Yeah.
But imagine that you have a time machine and you can fly back like 20 years.
Yeah.
What you will change, fundamentally in the infrastructure?
Yeah, that's a tough one. 20 years ago, we don't have AI, right? we had classical machine learning. Well, I think I will approach this in the following way. Like, I think there's a lot of investment in AI infrastructure right now, both at the hardware level and also at the software level, right? So we are getting a lot of things solved right now as we speak. So that's great. I think one thing that people may not pay enough attention to is probably, if you think about large-scale AI workloads, there are a lot of great frameworks, right? There's, PyTorch, there's JAX, there's also Ray and Hugging Face, right? There's a lot of great frameworks, but people may underinvest in what comes after, right? What comes after your AI team has programmed the training run or the model, right? What comes after you kick off the training, right? I think there's a lot of things that come afterwards, such as how do you monitor? How do you recover from failures, right? How do you even troubleshoot GPU failures? There's all kinds of GPU failures. Or when you are scaling your AI workloads, if you're scaling your AI team, people are fighting for GPUs, right? How do you deal with that? How do you have such a Datadog experience for AI monitoring, right? There's a lot of things that come afterwards that are, I believe, underinvested right now, right? So I would say if I were to choose something to focus on, that's what we are doing at SkyPilot. We are building a one-stop platform to really handle everything, right, for multi-cloud AI, from starting your jobs, monitoring it, orchestrating it, and so on.
Okay. Yeah. Interesting. And now let's use the same time machine, but this time we'll jump 20 years forward.
Okay.
From today, not from the previous point.
Yeah.
So what do you think if in 20 years we will have this infrastructure anywhere, abstraction of everything?
Yeah.
How the job of the AI researchers, AI people who's building AI will change?
People will raise their level of abstraction up the stack, right? It's always happened in the technology industry. 20 years from now, I certainly hope it's earlier than that. We are working toward that vision, right? Where compute becomes more abundant, more fungible, right? AI compute. And so I think people will raise their level of abstraction by focusing on the level above the compute. And so this is something about like, hey, I don't need to worry about, I have 10 clouds. Let's say I have 5 clouds, 10 clouds. I don't have to worry about how to schedule my workload, right? I just talk to this level above. I call it a compute intelligence layer, right? It's sort of like a distributed operating system. But compute intelligence captures the essence of it, right? I have a lot of compute down below. I want some intelligence layer on top to figure out the scheduling, to figure out the orchestration for me, to figure out how to increase the utilization, right? These are like tens of millions of dollars of clusters, right? I want to be able to utilize them as fully as I can. So I think people will focus on that layer more, and we are one solution toward that problem.
Thank you so much. It was amazing talk.
Yes.
I learned a lot about the history, about the challenges, and about the future that we will have.
Yeah.
I hope that we will see that.
Thank you, Alex.
Yeah. And thank you.
Thank you.
For being with us on the GTC.